unsaturated hydrocarbons, they can be again of two types. Alright, so it can be either alkenes or they can be alkynes. I told you carbon will form multiple bonds. So in alkenes, what it will happen? Alkenes have got CC double bond. Alright, and in alkynes, there will be CC triple bond. So if I write the general formula for an alkene, formula for an alkene, so general formula for an alkene will be CnH2n. Alright, CnH2n. So C is, so if I write, this will begin from at least 2 carbon. So because 2 carbon के बीच में एक double bond होगा, so that is if I write C2, so this will be H4. If I write C3, then it will be H6. Alright, so it will be H6. So C2H4, how we can write the structure of C2H4? That is C double bond. Since this is C2H4, the name will be what? The name is ethene. Over here, the name is propene. Alright, so that is when it is CC double bond, and we have to comply with the tetravalency of carbon. So that is one hydrogen over here, another hydrogen over here. Similarly, one hydrogen over here, this is one line, one hydrogen over here, another hydrogen over here, and this becomes C2H4. Similarly, if it is C3H6, then what we will make? One double bond, and this is like this, and then again make the tetravalency of carbon, that is one hydrogen over here. This is tetravalency of carbon is over. This carbon, it is having 3 bonds are already there, so make one hydrogen over here. This is one bond is over here, so make 3 hydrogen over here. So we have 1, 2, 3, 4, 5, 6 hydrogen and 3 carbon, C3H6. This is how is made the structure of carbon compounds. So that is, this is propene, this is ethene. Now let us see about alkynes. Alkynes, that is it will be triple bond. So general formula will be what? General formula for an alkyne will be Cn H2n minus 2. Cn H2n minus 2. So say supposing if I begin from the lowest member, that is ethyne, which is C2, and H2n minus 2, that means 2 2s are 4, 4 minus 2 is 2, so that is C2H2. If I write propyne, then this becomes C3, and this is 3 2s are 6 minus 2, that is H4. So how we can draw the structure of ethyne and propyne? Let us see how we can draw the structure of ethyne. Ethyne, that is, since it is yne, we can understand that there will be triple bond over here. CC triple bond is over here. Again, comply with the tetravalency of carbon. So one hydrogen over here, another hydrogen over here, and this becomes ethyne. Similarly, propyne, if you write propyne, then CC triple bond, and then another C, it will be having single bond, and then comply with the tetravalency of carbon. This is already 4 is completed over here, so this will be 1, 2 and 3 over here. So this is C3 and H4, which is known as propyne. Now what are the properties of alkenes and alkynes. Since alkenes are having double bond, alkynes are having triple bond, so they show addition reaction. They show addition reaction. They show addition reaction and alright. They show addition reaction, alkenes and alkynes, and they burn with a sooty flame. They burn with a sooty flame, which is also known as non-luminous flame. Non-luminous flame, which is also known as non-luminous flame. They burn with a sooty flame or non-luminous flame. Alright, so this is about properties of alkenes and alkynes. Hello students, so we were continuing with the carbon and compounds chapter. Alright, so in this chapter carbon and compounds, you have learned that the science of carbon compounds, that has got a special name, we call it as organic chemistry. Alright, now the compounds of carbon which contain only hydrogen and carbon, they are known as hydrocarbons. They are known as hydrocarbons. We had seen this, and these hydrocarbons, we could divide it into two classes. One is known as saturated. All this we have done in the previous video. Saturated. The other one is known as unsaturated. Alright, the other one is known as unsaturated. Saturated means there will be only CC, single bond. That is, we call this class as alkenes. And the general formula is CnH2n plus 2. For unsaturated, we saw that we have two classes which is known as alkenes and alkynes. Alright, alkenes have got the general formula CnH2n, whereas alkynes have got the general formula CnH2n minus 2. Alright. Now students, say supposing if you are given any compound. If you are given any compound, say supposing if I am given C3H8 and I am asked to write its name. So first thing what you should do is, you should see that the number of carbon is 3. 3 carbon, see when the number of carbon, we will be coming to the nomenclature. When the number of carbon is 1, then we call it as meth. When number of carbon is 2, we call the root name becomes eth. When the number of carbon is 3, then we call it as prop. Number of carbon is 4, we call it as but. When the number of carbon is 5, we call it as pent, and so on. Alright. So this we'll be doing details in the nomenclature of organic compounds. Now coming to this compound, say C3H8. This is C3 means this is prop. First thing, this is prop. Now whether this is propane or propene or propyne, how to distinguish between whether it is propane or propene or propyne? What we should do is always C check for the alkene first. Why? C, CnH2n. That means अगर ये C3 है और अगर H is just the double of it, 2 C3 means H अगर 6 होता तो then it would have been alkene. और अगर H 2n से ज़्यादा है, that means it is a alkane. If it is less than 2n, that means it will be an alkyne. So once again I'll advise you students, that is whenever you have to check for a compound whether it is alkane, alkene or alkyne, then first of all check the number of hydrogen, whether this hydrogen is equal to 2n or not. If it is 2n, that means it is alkene. If it is more than 2n, that means it will be alkane, and if it is less than 2n, that means it will be alkyne. So over here you can see this is 2n plus 2, so that means this is propane. Alright, if this is propane, if it was propene, then the formula would have been C3H6, and if it was propine, then the formula would have been C3H4. C3H4, it will be propine. Alright, now all these are, we will call it as, now let us see how we can form the structure of these compounds. So structure of organic compounds, how we are going to write structure of organic compounds. Alright, so whenever we have to draw the structure of organic compounds, so the various steps are that first is draw the carbon chain. Draw the carbon chain. Then draw the functional group. Whatever functional group, we will be coming to this term, what is functional group. There are different functional group, but whatever the functional group, say supposing if it is a double bond alkene or if it is a triple bond alkyne, whatever it is, draw the functional group. Kahan par hai? Let us draw that. Alright, and then suffice the tetravalency of carbon. So always see that carbon has got carbon is tetravalent, means there should be 4 bonds with carbon. Alright, so tetravalency of carbon. Now let us see for different alkenes. Alright, so first let me write you, we have got the root name. We were talking about this. This is, say, number of carbon atoms. If the number of carbon atom is 1, then the root name is meth. If it is 2, then the root name is eth. For 3, it is prop. For 4, it is but. For 5, it is pent. For 6, it is hex. Similarly, for 7, it is hept. For 8, it is oct. And for 9, it is non. And lastly, for 10, it is dec. Alright, now let us write about this. Say supposing if it is, we have to write the formula of methane. So this is an alkane, methane. So we will be writing 1 carbon and fill up the tetravalency of carbon. That means carbon should be making 4 bonds. So this is methane. If I have to write ethane, that means it is a 2 carbon compound, and again fill up the tetravalency of carbon. So this is ethane. Similarly, if I have to write propane, that means the root is 3 carbon and how many filling up the tetravalency of carbon. So this is C3H8, and we can draw like this all the number of carbons. Alright, Alright, now say supposing, now if I have to write for an alkene, alright, if I have to write for an alkene, then for an alkene the minimum will begin from 2. So for 2 I will be writing ethene if I have to write. Ethene means it is a 2 carbon, and since it is ene over here, that means there will be double bond between C and C. There will be a double bond, and again fill up the valency of carbon. That is, this is 2 bonds are already there. That means another 2 over here, another 2 over here. This is 1H. C2H4 will be the C2H4. Alright, similarly let us write for propene, the structure of propene. Since it is 3 carbon, so it is, first we will be drawing 3 carbon, and propene there will be 1 double bond. This double bond we can draw it over here also and over here also. For propene this is both is the same. Alright, propene. So over here again fill up the tetravalency of carbon. So this is already 3 are there. 1 more I have drawn over here, and this is 1, 2. So this becomes HH. As you can see, this is C3H6. Now let us see about butene. Now for butene, what it is, that means it is having 4 carbon. Alright. Now when I am writing butene, I have to specify whether this ene is on the first carbon or whether this ene is on the second carbon. So it should be either, if I can write but1ene, or I can also make but2ene. But2ene. So if it is but2ene, then if it is but1ene, then it will be, double bond will be over here. It is the same thing. If you draw it over here or over here, it is the same thing. Now if it is but2ene, then this becomes second carbon. This is, and again as I told you, you should complete the tetravalency of carbon. So this is 1, 2 like this. So tetravalency of carbon is completed. Alright, so this is but1ene and this is but2ene. This is about, these are known as straight chain compounds. These are known as straight chain compounds. Similarly, alkyne also we can see structure of alkynes. So that is C2H2. If it is alkyne, the first one member will be ethyne. Alright, so this is C triple bond. Since it is ine, so I understand that the functional group is 3 triple bond. So over here again, if I complete the tetravalency of carbon, this becomes C2H2. Similarly, for propyne, I can write that is C3. This is C3H4. So this is 1, 2, 3 bonds over here, and this is 1H. Tetravalency of carbon is completed. This carbon already tetravalency is completed. So over here this is like this. This is propyne. Alright. Now we have some cyclic hydrocarbons also. Let us see. Cyclic hydrocarbons also. Alright. Now these cyclic hydrocarbons, how we will draw the structure of cyclic hydrocarbons. Say supposing, for example, if I write cyclohexane, cyclohexane. Now since this is hexane, that means there is single bond over here. So let us see the formula. Now this will not follow, since this is cyclo over here, so this will not follow the formula, that is CnH2n plus 2. This formula will not be followed over here. We have C6H12. How it is? Let us see. C6. Now this is cyclo, means this will complete a cycle. So we will draw a hexagon over here. Cyclohexane. Now every time there is a single bond. Each point, this means one carbon. Each corner, this means one carbon. And over here, this is two bonds are already there. If I complete the valency of carbon over here, so this is like this, one H, another H over here, one H, another H over here, and this becomes C6H12, and this is known as cyclohexane. Alright, then another important compound which we will call it as benzene. Benzene. Now this is an ene, double bond. So over here, benzene, this is C6H6. Again, as you can see, this will not obey the formula CnH2n. This formula is not obeyed over here. For benzene, it is again a six-membered ring. Six-membered ring, remember, because benzene is a very important compound. So this is a six-membered ring, and since this is an ene, how it is? There is double bond over here, again a single bond, again a double bond, again single bond, and then again a double bond over here. So each corner, this denotes one carbon. As you can see, each carbon having three bonds. So all that you have to do is draw one H over here and complete the tetravalency of carbon. One H over here and complete the tetravalency of carbon. Alright, so this is C6H6, which we call it as benzene, and this is C6H12, which we call it as cyclohexane. Alright, now we have learned about hydrocarbons. Now let us learn about another term which we call it as homologous series. Now what is a homologous series? Alright, before this homologous series, we will discuss about functional group. We have been seeing that functional. Alright, so what is a functional group? This is a group of atoms which are attached to the organic compound and determine its physical and chemical properties. Determine its physical and chemical properties. Alright, so for example, we have such as one functional group is alcohol. So alcohol means there will be OH. OH will be, these atoms OH like this way, it will be attached over here. Then again, if we have aldehyde, then there will be CHO in the end of the compound. In the terminal, this is a terminal group, so we will be having CHO. Similarly, if it is a carboxylic acid, then we will be having the functional group COOH in the end. Alright, COOH in the end. So similarly, and just now you have already seen that if it is a alkene, if it is a ene, then we have got double bond, CC double bond. So this also becomes the functional group. Similarly, if it is a alkyne, then we have got CC triple bond. So all these, the properties of the compound will depend upon the presence of this OH or CHO or COOH, or as such double bond or triple bond. This will depend upon what the properties of the compounds will be, depending upon this functional group. Fine. Alright, so we will call it as the functional group, because the properties of compounds will depend upon how these groups are, how this how these group of atoms, they are functioning. Alright, so now let us come to another term which we call it as homologous series. Homologous series. Now, as the name implies, this is a series of compounds. Alright, so this is a series of compounds. Now, what is homologous? What we call it as homologous. So let's see, we will write it that this is a series of compounds having same functional group. All the compounds are having the same functional group. Same functional group. And since the functional group is same, so therefore their properties will also be same. A series of compounds having same functional group with similar chemical properties, and what is particular about it? And the two successive means just after one the other one, successive compounds differ by CH2, or if you talk it in mass, then this becomes 12 plus 2 or 14 grams in mass. Alright, so that is every time the next successive member, it will differ by CH2, or the mass will increase by 14 grams. Now let us see, for example, if we see that CH4, as you know, this is known as methane. Alright, this is known as methane. And if I write ethane, then this is C2H6. Now if I minus C2H6 minus CH4, then this is 1CH2. Alright, and the name of the compound, as you know, this is ethane. Alright, similarly, if I write methanol, then this becomes CH3OH. Alright, and if I write ethanol, then this becomes C2H5OH. Now, if you subtract this ethanol minus methanol, as you can see, you will again if you subtract it, the difference will be equal to 1 CH2. So this such series of compounds, similarly, that is, we will be having methane, ethane, propane, butane, and similarly methanol, ethanol, propanol, butanol, etc. So they will form a series of compounds, and these series of compounds we call it as homologous series. Fine. Alright, so we call it as homologous series. Alright, now there is another term which you should know, which is known as isomerism. 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 So iso of course means the same. Now what is same over here? That is when two or more compounds have the same number of atoms, that is same molecular mass, but different structural formula. Different structural formula. They are called isomers. Alright, so they are called isomers. Now simple alkanes show isomerism. Isomerism is of different types, but in your course you have to learn about only the simple one. Alkanes show chain isomerism. Chain isomerism. Alright, and the chemical properties may be different of these isomers. It may be same, but generally it is different of these isomers. Now let us see how we can draw isomer. Let us see once more. Isomerism क्या है कि जब दो compounds, दो हो, ज्यादा हो, कोई भी compounds हो, उनका molecular formula same है. ठीक है, अभी हम एक एग्जाम्पल से देखते हैं. उनका molecular formula same है, but उनका structural formula different है. तो ऐसे इस फेनोमेना को हम लोग कहते हैं आइसोमेरिज्म, है ना. और अगर इनकी चेन में फर्क है तो इसको हम लोग कहते हैं चेन आइसोमेरिज्म. फॉर एग्जाम्पल लेट अस सी, अगर हम देखें ब्यूटेन, ठीक है, तो ब्यूटेन इसको हम लोग आगे एन लगा देते हैं, भाई स्ट्रेट चेन है. ठीक है, ब्यूटेन का हमने क्या क्या एन है, तो इसका मतलब क्या होगा, ब्यूट है तो इसका मतलब हो गया 4 है, और एन है तो इसका मतलब होगा 2n + 2, दैट इज दिस इज 4 2 = 8 + 2 दैट इज 10, C4H10. अब n ब्यूटेन लगा हुआ है तो n ब्यूटेन का मतलब हो गया कि ये चेन जो है वो स्ट्रेट चेन है. ठीक है, और इधर हमने इसकी वैलेंसी को कंप्लीट कर दिया, तो ये बन गया मेरा n ब्यूटेन. ये हो गया n ब्यूटेन. ऑलराइट, अब अगर हम देखें आइसोब्यूटेन, आइसोब्यूटेन के लिए क्या होगा कि हमने क्या किया, इसमें आइसोब्यूटेन कैसे बनेगा, ये 3 कार्बन है और ये चौथा कार्बन जो है वो इसके साथ इसकी चेन फर्क हो गई. सो दिस इज as you can see, this is also having 10 hydrogen. So this is 3, 6, 9 and 1, 10 hydrogen. So they are both having the same formula. Formula is same, that means molecular mass is same, but the structure is different. We will be learning about nomenclature over here. So एक होता है IUPAC nomenclature. तो IUPAC nomenclature अभी हम पढ़ेंगे. IUPAC stands for International Union of Pure and Applied Chemistry. और ये एक बॉडी है जो कि डिसाइड करती है कि किस कंपाउंड का नाम कैसे लिखा जाएगा. तो ये IUPAC नोमेनक्लेचर है. तो IUPAC नोमेनक्लेचर में इसको N ब्यूटेन लिखा. इसको हम लोग क्या नाम देंगे, इसमें 3 कार्बन की स्ट्रेट चेन है और दूसरे कार्बन पे ब्रांच है. तो इसमें हम इसको देते हैं 2 मिथाइल. यहाँ पर ये एक कार्बन है, 2 मिथाइल प्रोपेन इसका नाम होता है. ठीक है, अभी हम लोग थोड़ा इसको डिटेल में और पढ़ेंगे. सो ओवर हियर वी वर टॉकिंग अबाउट आइसोमेरिज्म, दैट इज 2 compounds, they are having the same molecular mass, same molecular formula, but the structural formula is different. And this process is known as isomerism. Now, how isomerism? I told you this will change its physical and chemical properties also. All right. Now, now see the properties such as melting point and boiling point. Melting point and boiling point. What these melting point and boiling point properties, they will depend upon कि दो molecules के बीच में attractive force कितनी strong है. जैसे अगर ये एक molecule है और ये दूसरा molecule है, तो इन दोनों molecules के बीच में आपस में attractive force कितनी ज्यादा strong है. अगर जितनी ज्यादा strong होगी, that means जितनी ज्यादा strong होगी उतना melting point will be higher. Alright, and as you can see कि यहाँ पर surface area ज्यादा है. In the N-butane straight chain compound, the surface area is more. In the branched chain compound, the surface area is less. So therefore, what we can write? We can write that the straight chain compounds have a higher melting point than the branched chain compounds. Right? Straight chain compounds have a higher melting point than the branched chain compounds. Why this is now? The reason behind it is because the van der Waals force of attraction is stronger in straight chain compounds due to large surface area. So that is isomerism, and how isomerism is affecting. Now say supposing one last I'll do for this and then we will close with isomerism. Say supposing you are given any molecule, if you are given for heptane, if you are given, alright, heptane, that means C4H16 heptane, and you are asked to draw how many isomerism, how many isomers can exist, alright, how many isomers can exist for heptane. So what we will do, first of all, hept means I will be drawing 7 carbon, 1 2 3 4 5 6 7, and this becomes, this is N-heptane, alright. Then after that, take out 1 carbon and make a 6 carbon chain. This is a 6 carbon chain, and 1 carbon I can draw over here. Again, complete the tetravalency of carbon. So this becomes, this will be known as 2-methyl hexane. 2-methyl hexane. If I draw this over here or if I draw this over here, this is one and the same thing. So another one, what I can do is similarly 1 2 3 4 5 6, okay, and पहले 2 में draw किया था, अब 3 में draw करें. So this is alright. So this becomes 3-methyl hexane. Alright. Then after that, now let us make this a 5-membered chain. 5-membered chain, if I make it a 5-membered chain, then how I can write? If I make it a 5-membered chain, 1 2 3 4 5, alright, and I am making 2 carbons as, this is secondary 1, and then if I write over here another carbon. Alright, so this becomes, what will be the name for this? This will be 2 and 3. Since there are 2 methyl groups, so we will be writing dimethyl, and the parent name will be 1 2 3 4 5, that is pentane. Parent name will be pentane. So if I draw over here or this and this, again the name will be the same. If I draw this and this, or if I draw this and this, it will be the same name. Alright, then another what I can make is, another one I can make is what? Similarly 1 2 3 4 5, and then if 1 carbon is over here, another carbon is over here, then yes, so what will be the name for this? This will now become 2,4-dimethyl pentane. 2,4-dimethyl pentane. Alright, now let's see. We can also make this as a 4-carbon chain. So if I make it a 4-carbon chain, 1 2 3 4, and now 3 carbon. If I make it a 4-carbon chain, and now what I can do is, see if I am doing like this. See, as you can see, that this compound is same as this compound, because the chain over here, this will become a pentane. This will become a pentane. Alright, 1, 2, 3, 4, 5. So this compound and this compound become the same compound. So means I cannot make more than this. So this is now cancel. How many isomers I have in total? That is, this is 1, 2, 3, 4 and 5 isomers. For this heptane, I can make 5 isomers in all. Alright, I hope this is clear with you. सबसे पहले हेप्टेन के लिए क्या किया हमने? स्ट्रेट चेन कंपाउंड बना दिया. स्ट्रेट चेन कंपाउंड बना करके कार्बन की टेट्रावेलेंसी को कंप्लीट कर दिया. ठीक है, उसके बाद मैंने क्या किया, इसको स्ट्रेट चेन में से एक को कार्बन को हटा के एक कार्बन को ब्रांच कर दिया. ठीक है, ब्रांच का हमने नाम लिख दिया. ये ब्रांच आई, मिनिमम नंबर देंगे तो ये ब्रांच आई सेकेंड कार्बन पर. इसका नाम हमने रख दिया 2 methyl hexane. Alright, I wrote its name as 2 methyl hexane. Now say supposing थर्ड में मैंने क्या किया, इस मिथाइल ग्रुप को मैंने यहाँ पे शिफ्ट कर दिया. सो दिस बिकम्स 3 methyl hexane. Alright, then after that सिमिलरली मैंने इसको 2, 3 कार्बन चेन को और रिड्यूस कर दिया, 5 कार्बन कर दिया. दिस बिकम्स 2, 3 डाइमिथाइल. एंड सिमिलरली देन आई मेड दिस एज 2 and 4 dimethyl pentane. I can make it, and this is how we make. Alright students, now let us come today to an important topic, that is nomenclature of organic compounds. Nomenclature of organic compounds. Now for nomenclature, देखो ऐसे हम किसी भी चीज को नाम नहीं दे सकते हैं. ठीक है, नाम भी देने के लिए we have got a certain rules. Alright, now these rules, they are set up by what? They are set up by a body which is known as International Union of Pure and Applied Chemistry. Pure and Applied Chemistry. Alright, we call it as IUPAC. This is the body's name which is keeping the name, and this is setting up the rules. Now what rules are set up for this? Alright, so first of all, we have already learned about that there is a root name, and root name is based upon how many carbon we have. So if it is C1, then we call it as meth. For C2, we call it as eth. For C3, we call it as prop. For C4, we call it as but. For C5, we call it as pent. C6, we call it as hex. C7, we call it as hept. C8, we call it as oct. C9, we call it as non, and C10, we call it as dec. Alright, so this is the root name. Now after means this root name should be there, and then after this root name we will be attaching either a prefix according to the functional group, or we may attach the suffix according to the functional group. Now what all steps we are going to see. Alright, so that is the first step is select the longest carbon chain. Select the longest carbon chain in the compound. Whichever way the carbon compound is given, we should select the longest carbon chain what it is. Alright, now identify the functional group. Identify the functional group which is attached to this chain. Then give the proper prefix or suffix to the root name, give the proper prefix or suffix to the root name according to the functional group. Alright, according to the functional group. Then if more than one functional group is present, then use di, tri, tetra, etc. Di, tri, tetra, etc. Alright, then say supposing use di, tri, tetra, etc. Fine. Now say supposing if you have supposing you have so say that is what you should do, that proper whatever functional groups are attached, we will be writing the number according to that. Alright, so the functional groups, if not terminal, are given a proper position of carbon chain, this number should be minimum. This number should be minimum. Alright, now we will see point wise, we will see all this thing and we will see it already. Now first of all, say supposing I have to identify the longest chain. Supposing I have a compound like this, supposing I have a compound like this, alright, so I have a compound like this, so over here I have to identify which one is the longest chain. See how many chains we can have. One chain is like this. Alright, if I write like this, then this becomes, the root name becomes pentane, and the other chain is like this, so it becomes a hexane. If I am choosing this first one, then this becomes a pentane. If I am choosing this one, then this becomes a hexane. So what the name will be, that is I will be choosing the longest chain, that is hexane. And how I will be writing this accordingly, this is, say I told you that is ethane, for any alkane. Alkane, we had seen that this is CnH2n plus 2. This is known as alkane. Now, if I remove one H, that means if I make it as CnH2n plus 1, then this becomes alkyl. So, if the N is equal to 1, that means this is CH3, then this will be known as methyl. If it is C2H5, then this will be known as ethyl, and so on. So as you can see, this is 2 carbon over here, so this is the ethyl group. This will be known as the ethyl group. And what names I will be giving over here? See, if I begin the numbering from here, then this will become 1, 2, 3, 4, 5, 6, and if I begin the number from here, then this becomes 1, 2, 3, 4, 5, 6. So over here, if I am beginning the numbering from here, then this ethyl group is getting 3 number. If I am beginning the numbering from here, then this ethyl group is getting 4 number. So that means the smallest number what I will be giving is 3. The name will be over here, what I will be writing, 3-ethyl, and this is hexane. 3-ethyl and hexane. So that is, we have to, whatever, supposing if this is then ethyl, यहाँ पे कोई और दूसरा भी functional group होगा, तो we will definitely give the position of this, and accordingly we will be writing for it. Fine. Alright, now let us see, make a table and let us see that different functional groups and how we will be writing the names for it. Alright, so say supposing if I write functional group over here, functional group over here, and name over here. Name means whether this is a prefix or suffix. I should write prefix or suffix over here, and let us write one example over here and how we are going to make the structure of it. Alright, now functional group, say supposing first of all if I write an alcohol. Alcohol, the functional group is OH. Alright, and the name over here, this is either prefix or suffix. So we are going to write a suffix over here as all. Whatever the parent root name is, after the root name we will be writing all. So for example over here, if I write, this is, if I write OH like this, so the root name over here is 3, that is prop, and OH is attached on the second carbon. So the name over here will become what? Will become propan 2-ol. Propan 2-ol. So if it was attached with the first carbon, then we will be writing it as this will be written as simply propanol, or propan 1-ol also we can write, but it is generally written as propanol. Since it is over here, it is on the second carbon, so we will be writing it as propan 2-ol. Alright, then after alcohol, say next functional group, let us see aldehyde. Aldehyde, that is CHO. Now this CHO, this is a terminal group. This has to be written on the last carbon. Either you can write it on the, means whichever carbon, और जिस carbon के ऊपर ये attached होगा, end वाले carbon पे attached होगा, और जिस carbon पे ये attached होगा, उसी carbon को हम first name करेंगे. Right? So this is also, इसका suffix है, इसको हम लिखते हैं al. All right, so say supposing if I write over here, if I write CHO over here, and now this is counted as the first carbon, 1 2 3, so the name will become what? Propanal. 3 carbon की chain हो गई, so this will become propanal. Similarly you can take another example also. अगर हमने यहाँ पर लिख दिया इसको, ये CHO इस तरीके से होता है CHO, so alright, so this is now 4 carbon chain. We will be writing it as butanal. We will be writing it as butanal. Fine. Now after this aldehyde, now let us see another this thing, functional group. Alright, let us see another functional group. That is, functional group is carboxylic acid. Over here also, this is also a terminal group, and इसका क्या है? COOH. इसका suffix क्या होगा? जो भी root name होगा उसके आगे we will be writing it as oic acid. Oic acid. For example, if I write this is COOH, so this is 2 carbon, we will be writing it as ethanoic acid. रूट नेम क्या हो गया? 2 कार्बन का इथ, और इसके आगे हमने लगा दिया ओइक एसिड. इथेन के आगे ओइक एसिड. ऑलराइट, ओइक एसिड. सिमिलरली इफ इट इज अ 3 कार्बन, देन वी विल बी राइटिंग इट एज propanoic acid. We will be writing it as propanoic acid. और क्योंकि ये टर्मिनल ग्रुप है, इसलिए इसको हमें पोजीशन को देने की जरूरत नहीं है. ये ऑलरेडी नोन है कि ये वाला कार्बन जो है, दिस इज द फर्स्ट कार्बन. सो दिस इज कार्बोक्सिलिक एसिड्स. ऑलराइट, देन आफ्टर दैट you have ketone. Alright, so ketone is what? C double bond O, ketone. Alright, so ketone के लिए we have on. We will be writing it as on. So this is, say supposing if I write, और ये middle में होगा, कहीं पर middle में होगा. So this is, say supposing if I have over here, so इसका middle तो एक ही हो सकता है. So ये 3 कार्बन की चेन हुई, इसका रूट नेम हो गया प्रोपैन, और इसके आगे हमने लगा दिया ओन, सो प्रोपैनोन. ऑलराइट, अगर हमने इसको किया 4 कार्बन कर दिया, ठीक है, 4 कार्बन कर दिया, तो नाउ आई हैव टू स्पेसिफाई कि ये CO किस कार्बन के ऊपर है, वेदर इट इज, और इसको मुझे मिनिमम नंबर देना है. तो दिस बिकम्स, रूट नेम इसका हो गया ब्यूट हो गया, और ये सेकंड कार्बन के ऊपर हो गया. दिस वी विल बी राइटिंग इट एज ब्यूटान 2-on. ऑलराइट, देन नेक्स्ट फंक्शनल ग्रुप हम लोग देखें, दैट इज हैलोजन. हैलोजेंस अगर अटैच्ड है तो हम कैसे करेंगे? अगर हैलोजेंस अटैच्ड है तो हैलोजेंस के लिए कोई भी एक्स क्या हो सकता है? FCl, Br और आयोडीन. ठीक है, एंड इसके लिए हम प्रीफिक्स लगाते हैं, क्या, हैलो। हैलो मीन्स इट विल बी इधर फ्लोरो, क्लोरो, ब्रोमो, आयोडो, इसके लिए प्रीफिक्स लगेगा। सो से सपोजिंग इफ आई हैव दिस हैलोजन, और इसमें हमें पोजीशन को भी स्पेसिफाई करना होगा। सो दिस इज नाउ द रूट नेम ओवर हियर इज prop and chlorine is there, so we will be specifying the position. This is 2-chloropropane, 2-chloropropane. Let us see another example over here. So say supposing if I have one chlorine over here and another chlorine over here, this is all HH. So over here what I will be writing, this will become 1,2-dichloropropane, 1,2-dichloropropane. So this is about halogen. Then about alkene and alkyne we have already learned. Alkene and alkyne, so the suffix will be -ene, and over here the suffix will be -ine. The functional group is what? Over here it is C double bond C, and over here it is C triple bond C. C triple bond C is the functional group for alkyne, and for alkene it is C double bond C. So say supposing if I have if I have over here, so this becomes, the root name is prop, so this becomes propene. So this is for propene, you need not specify the double bond. Say supposing if it is butene, for butene, then you have to specify that this is on the second carbon, क्योंकि ये first carbon पे भी हो सकता था, first carbon पे नहीं है, second carbon पे है, तो हम क्या लिखेंगे, but2ene, but2ene. Similarly for a triple bond also, if I write over here a triple bond and accordingly carbon की tetravalency को complete करें, तो दिस विल बिकम प्रोपाइन एंड ब्यूटाइन अकॉर्डिंगली। कहाँ पर ट्रिपल बॉन्ड है उसको हमें स्पेसिफाई करना होगा। ऑलराइट, सो दिस इज बिकम्स अ वेरी इंपॉर्टेंट थिंग कि हम कैसे नोमेनक्लेचर करते हैं।